Namaste students. In this video we are going to balance a chemical equation or reaction. As I told you in the last class, we will have a special session for balancing chemical equations. First we can write an equation. For example, water. Water is formed from hydrogen and oxygen. They are the reactants and the product is water, H2O. So it is clear, H2 and O2 are the reactants, whereas H2O is the product. No doubt on it. So first we can draw boxes around each items, each elements. Here 2 reactants and 1 product. So now inside the box we are not going to write anything. We are balancing outside, that is left side of the box only. Now earlier we discussed about LHS, the term or the abbreviation, and RHS. Left hand side LHS and RHS right hand side. Left hand side to the arrow and right hand side to the arrow. So the elements present in the left hand side are hydrogen are there, oxygen is there. Okay, so equal to, in RHS right hand side there are also hydrogen and there are also oxygen. Now the number of atoms. Left hand side LHS, how many hydrogen atoms are there? 2. How many oxygen? 2. RHS right hand side, other side, hydrogen is 2, okay, and oxygen is 1. So here it is not balanced. In this case it is okay, but in the case of oxygen it is not balanced. So what we can do? So we can add a 2 in front of this initially. Okay, now oxygen, 2 oxygens are there. It is common for H2 and O. This coefficient, the 2 is called coefficient. It is common for H2 and this O. So here H2 also changed. H2 into 2, that is 2 into 2, 4. So here oxygen is balanced, 2, 2, left hand side 2, right hand side 2, but hydrogen is not so. So what we can do? We can just put a coefficient of 2 in front of this LHS hydrogen. It is 2 into 2, 4. So now 4 hydrogen here, 4 hydrogen here, balanced. 2 oxygen here in the LHS and 2 in the right side. So that also balance. This is a way of balancing a chemical equation. This finally we can write 2H2 plus O2 gives 2H2O. It is called a balanced chemical equation. 2 hydrogen molecules plus 1 oxygen gives 2 molecules of water. Thank you. Now we are going with the second example. So second example is zinc plus hydrochloric acid HCl, zinc plus HCl, that is zinc plus HCl gives zinc chloride and hydrogen. When a metal reacts with hydrochloric acid, hydrogen gas is released. You will learn soon. So as we know, LHS and RHS, initially we can draw boxes around each element. So please make sure that there will be sufficient space for putting a coefficient if needed. Here all these are inside boxes now. So now LHS, what are the elements? Zinc is here, LHS zinc, and hydrogen is there, HCl having hydrogen and chlorine. Here also zinc is there, chlorine is there, and hydrogen same. These are the reactants and these are the products. Okay, so how many zinc is there in the LHS? 1. How many H is there? 1. And how many chlorine is? That also 1. On the right hand side, how many zinc? 1 zinc. Chlorine is Cl2. Cl2 means 2. And H2, that is 2 atoms. So here there is an imbalance between chlorine, that is one chlorine in the left hand side, two chlorines are there on the right hand side, one hydrogen atom in the left hand side, whereas two in the right hand side. So there is a balance in the case of zinc, but in the case of H and Cl there is an imbalance. So okay, we can do. So to make it 2 H2, we can put a 2 here, okay, a coefficient 2 in front of the LHS HCl. So now this is changed, 2 HCl and 2 Cls are there. So the Cl case is balanced, 2 Cl. Now here it is left hand side, 2 chlorine atoms are there. Here also right hand side 2 chlorine, that is balanced. Already the zinc is balanced. Then in the case of hydrogen atom, H2 here and here also 2 H2, so that also balanced. So Zn plus 2 HCl gives Zn Cl2 plus H2. It is a balanced chemical equation. Zinc plus 2 molecules of hydrochloric acid gives zinc chloride and hydrogen gas. Hope it is clear. Thank you. Now we are moving with the third example, that is hydrogen plus nitrogen gives ammonia, NH3. So hydrogen plus nitrogen gives ammonia. We wrote the skeletal equation as we know. Now we are balancing the equation by using LHS and RHS method. So before counting, we are drawing box around each components here. So on the left hand side, the elements H is there and N, hydrogen and nitrogen. On the right hand side also the same as we can write, hydrogen and nitrogen. Okay, first one is hydrogen followed by nitrogen, then it is easy to identify also. LHS, how many hydrogen atoms are there? 2. How many nitrogen? 2. On the other hand, RHS, right hand side, N1 and H3. Oh, there is a imbalance between both sides, both sides also both elements. So what we can do? We can just here we need 3H. Suppose we are putting 3 here, there may be 6. So anyhow we may try with 3H2. 3H2 means 3 into H2. 3 into H2 means 3 into 2, 6. So 6 hydrogen is here, and in the case here 3 only. So suppose we are putting a 2 here, 2 into 3, then it will be balanced. 2 into 3, 6. So 6, 6, it is balanced. In the case of nitrogen, here now it is 2. This is the coefficient is common for both hydrogen and nitrogen. So now it is 2. Now we will look at it. Hydrogen 6 molecules on the LHS and 6 molecules on the RHS, balanced. Nitrogen 2 in the left and 2 in the right, that also balanced. So the equation is balanced. So balanced chemical equation is like this: 3H2 plus N2 gives 2 molecules of NH3. 3 molecules of hydrogen reacts with 2 molecules of, a single molecule of nitrogen gives 2 molecules of ammonia. It's a type of combination reaction also. 2 reactants combines to form a new product. It is an example for combination reaction also. Thank you. Hi students, here is a homework for you to balance the following chemical equations. As we learn 3 reactions, how to balance 3 reactions we learned already. So I request you people to go through the 6 homeworks given here, and it will be posted in our group in Word format also. Thank you.